Here's a lesson on partial fraction decomposition. It sounds complicated and it is a mouthful, but all it means is that given a rational expression, we want to find out the fractions that were added to get the rational expression. So the first thing that we have to do is we need to go ahead and factor the denominator, which will be x minus 1 times x plus 1 times x plus 2. And then we'll set that equal a over x minus 1 from here, b over x plus 1 from here, and finally c over x plus 2 from here. And then to solve for the values of a, b, and c, what we want to do is we want to take this entire equation and multiply by the common denominator, which of course is the x minus 1 times x plus 1 times x plus 2. So let's begin. If we take the common denominator, multiply to the left side of the equal sign, everything in the denominator gets canceled out and we're left with just 5x plus 7. Next, if we take this multiply here, then the x minus 1 gets canceled out, this, and we're left with a, which is from the numerator, times x plus 1 times x plus 2. And if we take this and multiply here, again, the x plus 1 gets canceled out along with this. And we have b, again, from the numerator, times the x minus 1 and the x plus 2. And finally, if we take this, multiply to the third fraction here, then the x plus 2 gets canceled out. We're left with c times x minus 1 times x plus 1. And then what we want to do is multiply x plus 1 times x plus 2, x minus 1 times x plus 2, and also x minus 1 times x plus 2, which gives us this equation. And then we want to take that a, distribute it into the parentheses, the b, and also the c into the parentheses as well, where we end up getting this equation here. Next, we need to go ahead and group the like terms, meaning we want to go ahead and group the ax squared, bx squared, and the cx squared since they all have x squared next to it. And then we want to go ahead and group the 3ax, the bx, since they have x next to it. And finally, we want to go ahead and group the 2a, negative 2b, and negative c, since they do not have x next to them. And once we complete the grouping, it gives us this equation here. Finally, to solve for the a, b, and c, what we want to do is we want to let a plus b plus c equal 0. Why? Because if you look on the left side, there is no x squared, meaning the coefficient of x squared, or a plus b plus c, has to equal 0. And then the coefficient of x, or 3a plus b, will equal 5. Since on the left side of the equal sign, we have 5 as the coefficient of x. Finally, we want to let 2a minus 2b minus c equal 7. Since we have a 7 on the left side that has no x next to it, and since we have 2a minus 2b minus c that has no x next to it on the right side, we'll set that equal 7 as well. And to solve for the values of a, b, and c, what we want to do is we want to write a system of equations like this, where we have a plus b plus c equals 0 from here, and 3a plus b equals 5 from here, and finally the 2a minus 2b minus c equals 7 from here. Next, what I want to do is I want to go ahead and take the first equation and then the third equation, write them on top of each other, and then add it up and down, where I get 3a minus b, and notice the positive c and the negative c cancels out, which is what we wanted, equals 7. And then we want to use that 3a minus b equals 7, combine it with the second equation that we had, the 3a plus b equals 5. Using elimination, we could solve for the value of a. 3a plus 3a is 6a, negative b, positive b cancels out, and we have a 12 on the right side of the equal sign, or a equals 2. Then we'll take that 2, plug it into this equation right here. So it'll be 3 times 2 minus b equals 7, or we get 6 minus b equals 7, or we get b equals negative 1, where again, we'll plug it in for the value of b into our answer. Finally, we need to go and solve for the value of c, and to do that, we'll plug it into our very original equation, where a is 2, b is negative 1, and of course, c equals 0, or c equals negative 1. Again, we'll go ahead and plug that into the equation where c value is negative 1. So as you can see, the partial fraction decomposition, it is very tedious and it does become a very long question. However, you just need to take your time and not make any mistakes. Most mistakes that occur when we do the system of equation, where we do eliminations and solving for the values of a, b, and c. And I hope you enjoyed this lesson. And as always, thank you very much for watching my videos. And if you haven't subscribed, please do. Don't forget to hit that like button.